In this lecture, I am going to solve some problems on non-homogeneous linear equation. Come on, hello students. Solve d square plus d dash plus d dash minus 1 into z, that is equal to e power minus x. Students, e power minus x. Now solution. What is complete solution, students? That is equal to complementary function plus particular integral. Complementary function plus particular integral. Now see the students here, f of d comma d dash. Here we have d square plus d dash. Up to here, okay students, we have d dash. D dash means what is order? Order is 1. Here the order is 2. Here order is 2, but here order is 1. So this is non-homogeneous equation. What students? Non-homogeneous equation. Now in non-homogeneous equation, what is factor form, students? What is factor form? D minus md dash minus c, students. D minus md dash minus c. Now how can you express this like the students? D minus md dash minus c. Think here. Right? Here, observe here d square minus 1, students. So this can be written as d square minus 1 square plus, from these two terms taken common, d dash, students. D dash, we get here d plus 1 into z, that is equal to e power minus x. E power minus x. Now d square minus 1 square, students. A square minus b square. A plus b into a minus b. So we get here d plus 1 into d minus 1 plus d dash into d plus 1 into z, that is equal to e power minus x. Now common term, students, here we can take common d plus 1. So you get here d plus 1 into d minus 1 plus d dash. D plus d dash minus 1 into z, that is equal to e power minus x. E power minus x. Now here we have two factors, students. Now compare with this. You compare with this, students. Here we don't have d dash coefficient, students. So m1. So this is m1. M1 value how much, students? M1 value is 0. Now C1 value, students. Whenever is m1, say it is C1. C1 minus C here, students. If you observe here, minus C. So you can write here minus 1. Minus 1. First one completed, students. Go to second factor here. M2. M2 is equal to here minus m, students. So here we have plus. So minus 1. And C2 is equal to minus 1. Here we have minus C. So C2 value is 1, students. C2 value is 1. Once again, D plus D dash. There is no D dash term. So M1 is equal to 0. Here minus C, students. So here we have plus 1. So this can be written as minus of minus 1. So C1 is minus 1. M2. M2 is here. In the formula we have D minus M, D dash. So minus M. So here we have plus M, students. So minus of minus 1. So M2 is minus 1. So it is, in the formula we have minus C. Here we have minus 1. So C2 is equal to 1. C2 is equal to 1. So what is complementary function, students? Complementary function. Come on, tell me. E power minus x, e power 7x. F1 of y plus m1. M1 value is 0. So F1 of y plus C2 here. E power C2 is 1. So x. F2 of y plus m2x. So if we have minus, so we get a minus x. This is the complementary function, student. This is the complementary function. This is the complementary function. Now, particular integral, students. What is particular integral? Particular integral is, you take this one, students. 1 by d square plus d dash plus d dash minus 1 into e power minus x students, e power minus x, that is equal to 1 by, here a value is a value is minus 1, b value is 0 students. So here we get here minus 1 whole square. Minus 1 whole square means we get minus 1 plus d dash quotient is 0, so 0. D dash quotient is 0, so 0. Replace with 0. Minus 1. 1 minus 1, that means here we get here f of a comma b is equal to 0. F of a comma b is equal to 0. Now students, now. Okay. In such case, when f of a comma b is equal to 0, that is equal to, you differentiate the denominator with respect to d students. So 1 by d, dou by dou d. Okay students, dou by dou d into d square plus d dash plus d dash minus 1 into e power minus x, that is equal to, see students, come on, tell me, 1 by derivative of d square students, we get here 2d. I forgot here students, after derivative you multiply with x students, okay, 2d. Here dou by dou d of d students 1, so you get here plus d dash, dou by dou d of d dash students, with respect to d dash is constant, so the value is 0. 1, derivative of 1, this value also 0, into x e power minus x, that is equal to, replace a d by minus 1, d dash by 0, so you get here x by 2 into d value is minus 1, so minus 1, d dash value is 0 into e power minus x, that is equal, we get here minus x by 2 e power minus x, which is the particular integral of given problem. Therefore the complete solution z is equal to, what is the solution students? E power minus x f1 of y plus e power x f2 of y minus x minus here x by 2 e power minus x, which is the required solution of given problem. Let us see the another problem student. Right on students, solve d square minus d dash plus d dash minus 1 into z, that is equal to cos x plus 2y, Now solution students, again complete solution, complementary function plus particular integral, complementary function students, complementary function. Now in the complementary function we have to write this f of d comma d dash as d minus nd dash minus c. Once again, by observation here, d square minus 1 students, it can be written as d plus 1 into d minus 1. From these two terms we can take in common students, minus d dash, we get here d minus 1 into z, that is equal to cos x plus 2y, Now come to tell me students, what is common factor here? Take common d minus 1. Then we get here d plus 1 minus d dash. So write a proper order, d minus d dash plus 1 into z, that is equal to cos x plus 2y, Now compare students, compare. Here m1 is equal students, there is no d dash terms to students, so the value is 0, comma c value c1 say 1. Here m2 is equal to 1 students, c2, there we have minus c students, but we have plus 1, this plus conversion minus of minus 1, so c2 value is minus 1. Therefore the complementary function e power 1x into f1 of y plus 0 into x students. So y f1 of y plus e power minus x f2 of y plus x students into value 1. So this is complementary function. Complementary function. Now particular integral students. Particular integral. Particular integral. Here I am taking here 1 by this one students. D square minus dd dash plus d dash minus 1 into cos x plus 2y. Cos x plus 2y. That is equal to, everybody knows students, d square by minus a square and d dash by d dash square by minus 2 square. Everybody knows. So 1 by d square students minus 1 square minus into dd dash students minus 1 into 2 students minus 1 into 2 plus d dash minus 1 into cos x plus 2y. Because we know whenever there is square, then only we can replace students. If there is d dash, we cannot replace. So that is equal to 1 by minus 1 minus into minus plus 2 minus 1 plus d dash minus 1 cos x plus 2. Now minus 1 plus 1 cancel here. 1 by d dash students. 1 by 2 dash means integrate with respect to y. So cos x plus 2y dy. So that is equal to, what is the integration? Sin x plus 2y by 2. Sin x plus 2y by y coefficient is 2 students. So get 2. Therefore, what is complete solution students? That is equal to z, that is equal to complementary function e power x f1 of y plus e power minus x f2 of y plus x plus 1 by 2 sin x plus 2y. This is the required solution of given problem students. Hope you understand this problem. Thank you for watching this video. Jai Hind.